In this lesson, we're going to work to understand the distribution of the sample mean. To do that, we need to remember that in order to describe our distribution of that sample mean, we're going to identify the shape, the center, as well as the spread. We're going to do that using the distribution of the sample mean that's coming from a normal population, and the example we're going to use is talking about IQ scores. So let's suppose that the IQ, some variable of a human, is approximately normally distributed with a population mean of 100 and a standard deviation of 15. So IQ scores in general are normally distributed with this mean and standard deviation. Suppose that we want to take a sample of size 10 from this population's distribution. We're going to do a simulation in StatCrunch to examine this question. Let's start by simulating. So data, simulate, normal. We're going to start by simulating collecting that sample of size 10. And I'm going to repeat this process 500 different times. So I'm going to go out and I'm going to collect the IQ score from 10 randomly selected people, and I'm going to do that, repeating that process 500 times. Now we're told that our mean for IQ scores, the population parameter is 100 and our standard deviation is 15. I'm going to add in a header for each of my samples just to keep it clear, and I'll hit compute. So what we're looking at here are 500 different samples, and each one of these samples contains the IQ score from 10 randomly selected different people. So I have IQ scores in this last sample here ranging from 76.25 all the way up to, it looks like, 141. And you'll notice that for each of these columns that you see, there is a different set of 10 IQ scores, and that makes sense because we're sampling from a population, and I'm collecting 10 samples, and then I repeated the process each time talking to 10 new people. Now, each one of these 500 samples it's going to have their own mean and standard deviation. So each one of these samples has their own sample mean and sample standard deviation. So we're going to look at that value now, and we can quickly use StatCrunch to find that using stat summary stats column. And I want to know what is the sample mean and sample standard deviation for each of these 500 samples. So when I hit compute, I had 2 more columns that were added here. In fact, I'm going to change the header here to indicate that this is the sample mean and this is the sample standard deviation. So just to clarify, this first cell right here is going to be the sample mean from the first 10 IQ scores I collected. So I found out that if I took the average or the mean of those 10 scores, then its sample mean is going to be 92.58. And then the next one. So I have a new set of 10 IQ scores, and their average would be 98.6. And you can see that I'm going to keep getting different sample means for each of the 500 different samples that we looked at. We talked about our sampling distribution, and when I look at a sampling distribution, I'm interested in the shape of that overall distribution, the center, and the spread. The sample distribution I'm referring to is the distribution or shape. If I were to take all 500 of these sample means and graph it using a histogram, I wonder what that shape would look like. So remember, our sample means is going to be a continuous variable because you can see we have all these different values showing up. So I'm going to go graph, histogram, scroll down to the bottom, and I want to create a histogram for the sample mean column, and I'm going to add the average of that column to the histogram. So now when I look at this histogram on the screen, if I asked you to describe the shape of this histogram, hopefully you would be able to say that that's got a normal distribution. So what we're looking at here is this is the result. This histogram here is the result of all 500 of my samples over here, where each one of those 500 samples has their own average IQ score from the 10 people we talked to. And we also notice, because we got the shape now of my sample distributions, the center of that sample distribution is going to be the mean of all 500 of these samples. So the mean of all 500 of these samples ends up being 100.17. So this is what we're referring to when we are talking about the shape, the center, and the spread of our sample distribution. Now, I want to come back and I want to use a different applet to talk about spread. So let's pull up a sampling distribution. We're going to still use this idea of IQ scores that have a population mean of 100 and a standard deviation of 15. So I'm going to hit compute here. I'm going to make this a little larger so we can see what's happening. And what the top row of this applet is representing is the distribution of my population. Distribution meaning the shape is normal, the center is 100, and the spread is 15. What would happen to this if I sample a size 10? So let's repeat our simulation we did a moment ago, but this time using a different output. I have a sample of size 10, but I'm going to do it not 500 times, but 1,000 times this time. So if I click 1,000, you notice I have a histogram here at the top and a histogram down here at the bottom. Just ignore the part that's in the center for right now. The histogram at the bottom, this green histogram, represents the same type of thing we created in our blue histogram a moment ago from our 500 samples, only this time we sampled 1,000 different times, a group of 10 people, and these are the results of all 1,000 different samples that we collected. Notice that the shape of my sample distribution is normal, just like the shape of the population is. The center of my sample distribution is 99.95, which is pretty darn close to the center of my population. The standard deviation of my sample distribution is 4.8, and so we can see that that is much less than the standard deviation of our population that we started with at 15. And that makes sense because if you were looking at our histogram here at the bottom, the green histogram, you'll notice that although both the population and the sample means have a normal shape, the distribution of all 1,000 sample means down here is somewhat skinnier, right? So we have less spread, so the data is more concentrated around the middle, which the number of our standard deviation from the sample means supports. Now, let's do one more simulation. This time, let's talk about a sample size of 25. So I am going to go out and instead of collecting 10 samples, or instead of talking to 10 people, I'm going to talk to 25 people. And I'm going to repeat that process, collecting 25 different IQ scores, and I'll repeat that process 1,000 times. So again, if I ask you about the distribution of our sample means down here at the bottom, the shape of all 1,000, this is what this histogram represents, right? It's the result of all 1,000 samples. The shape is still a normal distribution, just like the shape is of our population. The center of our sample distribution is 100. In fact, it's even closer than it was just a moment ago, but that's pretty much the same center as what we see for our population. The spread of our sample distributions has gotten even smaller at 3. So the shape of our sample distribution is normal. The center of our sample distribution is almost 100, and the spread of our sample distribution is somewhat smaller. So I can summarize these findings that we found from each of our 2 simulations over here from StatCrunch. I can summarize that information here at the top of your screen on the left in red. If I sample a population that's normal, then the distribution of my sample means X bar is also going to be normal, which is what we saw here. If the mean of our sample means is going to be equal to the mean of our population that you see above here. The standard deviation of our sample means, remember that's down here in the bottom of our graph, the standard deviation of all of those sample means is going to be less than the standard deviation of our population. And then we could also see that as the sample size was increasing, so when we went from a sample size of 10 to 25, the standard deviation of these sample means is going to decrease. And then finally, if we have a random variable x, which is what we started with from our population, as long as that is normally distributed, then we see that the distribution of our sample means is also going to be normally distributed. So what we're saying in red over here in words is what we saw happen over here in the simulation from StatCrunch. And we can summarize that information using these 2 formulas right here. These are the formulas for our sampling distribution of our sample means. So, like we say in this second bullet up here, when the mean of our sample means, mu of x bar, is always going to be equal to the mean of our population. So the mean mu of our sample means, x bar, is always equal to the mean of the population. We saw that the center of our population's distribution is the same as the center of our sample distributions. And then we can calculate, which we will be doing by hand, this standard deviation of the sample means, which is changing, by using this formula here, which says that the standard deviation of the sample means, so sigma x bar, is equal to the standard deviation of the population divided by the square root of that sample size. So it's the sample size which is driving the overall standard deviation of our sample distributions. So hopefully this is an explanation that helps you to understand what it is we're talking about when we want to talk about the sampling distribution of our x bar or the sampling distribution of the sample means.